Good morning, everyone, and welcome to Waste as an Energy Opportunity webinar. We have a full agenda for you today with 5 speakers altogether. We're going to be starting off with Jennifer Barron, Business Manager at Covanta, who will be presenting with Joseph Anello, who's a Manager for Waste Planning at the Region of Durham. And they're going to be talking about landfill waste as an energy opportunity and the landfill diversion strategy at the Region of Durham. We'll then follow that up with Stephanie Thorson, Associate at Biogas Association, and Frank Gazzola, Superintendent of Energy Engineering at the City of Hamilton. And they're going to be talking about opportunity Good morning, everyone, and welcome to the Waste as an Energy Opportunity webinar. We have a full agenda for you today with 5 speakers altogether. We'll be starting off with Jennifer Barron, Business Manager at Covanta, who'll be presenting with Joseph Anello, who's a Manager for Waste Planning at the Region of Durham. And they're going to be talking about landfill waste as an energy opportunity and speaking to the landfill diversion strategy at the Region of Durham. We'll follow that up with Stephanie Thorson, who's an Associate with the Canadian Biogas Association, who'll be presenting with Frank Gazzola, who's a Superintendent of Energy Engineering at the City of Hamilton. They'll be speaking to the opportunity in organic waste and profiling Hamilton's biogas activities. Finally, we have Kieran McConnell, who is the Manager of Neighborhood Energy at the City of Vancouver, and he'll be talking to the opportunity in waste heat. So thanks very much for joining us, and at this point I'd like to turn it over to Jennifer to get us started. Go ahead, Jennifer.
Joseph Anello and I will be presenting in regards to the Durham York Energy from Waste facility, which is owned by the regional municipalities of Durham and York, and is designed, built, and is currently being operated by Covanta. I am the business manager at Covanta, Durham York Energy Center, and Joseph Anello is, can introduce himself, I suppose, works for the waste department with the regional municipality of Durham. Joseph will be presenting the first part of the presentation in regards to the region's presentation of the Durham York Energy Center, but I see that Joe is still on mute. There we go. So Joe, if you'd like to take it away.
Oh, thank you. Hi, well, thanks very much, Jennifer. Yes, excellent. If we can just start, maybe I can just introduce the region. So I'll be speaking to the Durham region with regards to this project. We are a fairly large municipality, urban and rural, quite a large space of land. We have, our population is just over 600,000, and we expect to reach 1 million by 2000, and that basically includes the region, which is 8 municipalities. We have Pickering, Whitby, Oshawa, Clarington, and then north we have Scugog, Uxbridge, and Brock. The region itself is responsible for the pickup of garbage or waste at 6 municipalities, and Blue Box at all the remaining 8. We are responsible for the disposal of all waste, residential waste in the region. The project that I was going to speak to is the Energy from Waste facility. Now, it is a project that was long in coming and took a lot of planning. So we started off in 2005 with an agreement to undertake the Energy from Waste facility and the EA. At that time, we also developed our partnership with York. We did our terms of reference for the environmental assessment in 2006. It wasn't until 2009 that we actually submitted the environmental assessment, and by the time we got approval, we had to go through quite a long process for public and agency review. So you can see that we did over 100 public consultation and workshops. It was a very well publicized project. We were rated News Story of the Year, and we think we did a good presentation and a good public consultation on this project, and the ministry agreed with us. In November of 2010, they gave us our approval to go forward. But there was quite a few decisions that actually had to be made prior to us moving into this. Next slide, Jennifer. We undertook a long-term waste management strategy study in 1999, and that was a combination of regional individuals, municipalities, and public. And one of the conclusions there was that we investigate resource recovery through an energy from waste system. And it also introduced other diversion projects. The whole idea of the 1999 long-term waste strategy was to increase our diversion. We had a 60% diversion target at that time, which you can see subsequently our council increased that to a 70% diversion target. One of the other things that the council direction gave us was that they indicated to us that we would not create any new landfills in Durham, and that our disposal or recovery solution would be a made-in-Durham solution. Therefore, it would bring business to the Durham region. Next slide, please. So I spoke to the timeline, how we actually got to our approvals. Once we got to our approvals and we got our certificate of approval in 2011, we actually moved into the notice to proceed. So we had a RFP process where we selected Covanta as the preferable design, build, operate company. They then started the design build commencing in 2011. It was a 40-month project. We are currently in the commissioning stage, and we are estimating at this time that commencing in September of this year, we will be completing our acceptance testing and move into commercial operations by the end of this year. Next slide. So one of the things with our facility is that its total capacity is 140,000 tons per year. Of that capacity, York Region has 30,000 tons, and Durham Region has 110,000 tons. The amount of tonnage that we sent to landfill last year was about 110,000 tons. Therefore, diversion for us is a very important part of this project, such that we can extend the longevity of this project and put into the future as long as possible any need for expansion of the facility. So in order for us to do that, we have quite an extensive diversion program here that takes us to 55% diversion. We do everything from blue box, green bin, yard waste, bulky waste, electronics, batteries, and a whole slew of other things. One of the activities that we're undertaking now, which we feel is very good for our EFW, is to try to get out of the EFW any non-combustibles. So any construction materials such as rubble and asphalt or metals, anything along that lines that really has no combustion value, we're trying to get that out now. We have a pilot project that we have undertaken this year for our construction and demolition waste, trying to divert that from the EFW. The next thing to support our EFW is we will actually want to divert more hazardous waste out of the stream. Towards that end, we are building a new hazardous waste depot in the Clarington municipality, and that should be up and running next year, hopefully to take more hazardous waste out of our system. Next slide, please. So our sustainability section here has created a local action plan on climate mitigation. And within that plan, there are some projects that are actually related to waste. We have reuse days here, which we are undertaking on a monthly basis. We make it available to our residents, and we partner with NGOs such as Salvation Army, and they actually run the facility. We help with the promotion. We are also looking at biomethane production at our landfills, and if we can use that, and any other opportunities for using any gas which is currently flared within our EFW to generate more electricity. So that introduces our Durham project. I guess I have the next slide too, Jennifer.
We can transition anytime you'd like.
So what we have, would you like to transition here, because now you're getting into the actual Durham waste facility?
Sure.
So if I can pass it over to you, Jennifer.
Thank you so much, Joe. The municipal solid waste collected in the region of Durham is brought to the region's transfer stations for sorting, inspection, and bulking. Once that's been completed, the waste is then reloaded into 53-foot walking floor transport trucks, and that's how the waste arrives at the Durham York Energy Center. One of the purposes of that is to reduce the amount of trucks on the road, which reduces our greenhouse gas emissions and makes it a little bit more economical and streamlines the process to get the waste to the facility. Once the waste is received at the facility, it is unloaded either onto the tipping floor for a secondary inspection or directly into the pit, and that in that way is processed through the Durham York Energy Center. Most importantly, and to Joe's point, no loads of divertible materials or recyclables are accepted at the Durham York Energy Center for processing, which means we do not process any blue box or green bin waste. Those loads do not come here for processing. As Joe mentioned, we do process a maximum of 140,000 tons of post-recycled waste per year, which will generate approximately 17.5 megawatts of energy, which is enough in Durham Region considering our consumption patterns to power approximately 10,000 homes annually. The facility is one of the newest in North America, the newest on a greenfield in over 25 years, and it is the cleanest and most efficient energy from waste facility in North America, if not the world. And our hope is that it will help the regions of Durham and New York achieve their diversion targets of 70%. So a little bit about Covanta. We operate about 46 energy from waste facilities globally. Predominantly they are located in the United States. However, we have a few in Europe and in China, and we are building our newest facility in Dublin, Ireland. That facility in Dublin is an 800,000 ton per year facility, so it's a much larger facility. Generally speaking, the Durham York Energy Center is one of the smaller facilities in our fleet. We have two facility models, the first being a service facility, which is the Durham York Energy Center model, where the facility is owned by a municipality and operated by Covanta. Our second type of facility that we operate are merchant facilities, where they're generally owned by Covanta or split owned between Covanta and a local municipality, but for which Covanta has more flexibility in the operation of waste coming into those facilities. Together with those 46 facilities globally, we have some pretty impressive statistics. We collect enough ferrous metal, which is magnetic types of metal, to build over 90 CN towers per year, and enough non-ferrous metals such as aluminum to produce over 1 billion aluminum beverage cans per year. So that helps put into context not only the diversion from landfill, but associated diversion in terms of mining and production and smelting for new ores that are avoided because of our ability to recycle those metals instead of them going to landfill. So briefly, a description of how the waste moves through the facility. To your right, to the left of the screen, you'll see the truck unloading its waste into the pit. We have 2 grapples. Each grapple takes approximately 3 tons of material and puts it into the boiler feed chute. At this facility, we have 2 boilers that are fed continuously 24 hours a day, 7 days a week, although we only receive waste between 7 a.m. and 7 p.m. Mondays through Fridays. Once the waste is put into the feed chute, a ram pushes the waste into the boiler at a very specific and set rate, and it takes the waste approximately an hour and a half to move through the boiler system on a series of rotating grates. Once the material has moved through the system, we are left with 2 different streams. The first stream is the bottom ash stream, and that is the ash and metals, the non-combustibles that come out the bottom of the grate system. Those are separated on a grizzly conveyor. The ash is sent for testing. It is non-hazardous material, and it meets the requirements of Regulation 347 for non-combustible and non-hazardous material. It is then sent to landfill for beneficial reuse as daily cover. However, there are options to reuse the bottom ash within aggregate properties or in roadbed or paving applications. So we will be investigating those once the facility is commissioned. The aluminum, the non-ferrous, and the ferrous materials are also sent away for recycling, and all of that is sent locally right now for recycling. The second stream of material coming out of the incineration process is the fly ash material. So as energy is produced, the walls of the boilers are lined with pipes containing water. That water is superheated, and that superheated steam is what powers the turbine, which produces electricity. Once the steam has moved through the turbine, it enters what we call our air-cooled condenser, where it goes through multiple passes, where it's cooled down and turned back into water and recirculated through the system. So this facility is a zero waste wastewater discharge facility. As the air from the boilers moves through the system, it goes through a few pieces of technology that reduce pollution in those gases. The first is what we call our bingo mill, which is an apparatus that contains balls, and we inject carbon into that, and the carbon reduces quite a few of the emissions that way. And then all of those gases are put to our air pollution control tower, our bag house, where it's filtered through thousands of filter bags that are lined with lime. The small particulates attached to the lime, and then every few seconds those bags are puffed, and all of that material, the fine particulates in the lime, they fly down to the bottom and are collected in a separate stream as fly ash, which we then combine with cement and a cement-like product called pozzolan to encapsulate it. We keep that on site for 5 days, although our testing at this point has shown that it's fully encapsulated and non-leachable within 1 day. So the technology at this facility has been shown to be incredibly effective at reducing emissions. The sustainable waste management, in terms of the EPA and the European Union, have ranked the environmentally sound strategies for managing waste in an inverted pyramid diagram. And prior to disposal, if you can recover anything out of the waste that is possible, that is the preferred method. So at this facility, we send very little away to landfill, and we recover energy from as much as possible. In terms of putting into perspective with other energy from waste or other energy sustainable solutions, renewable energy sources, EFW facilities take up the smallest footprint of land. So on average, approximately 0.7 acres per megawatt for EFW facilities versus landfill gas to energy, which of course have the footprint of the landfill, so they're quite large. Solar farms also have quite a large footprint, and so do wind power farms, even more than solar. So for the amount of energy that is produced, energy from waste facilities are one of the most beneficial renewable energy sources. Here's a summary of our air emission standards, where we compare the Durham York Energy Center in the green column to the other guidelines that are available globally. We have the Ontario A7 guidelines, the US EPA guidelines, and the EU guidelines, as well as the guidelines associated with our newest facility that is under construction in Dublin. You can see that we meet, if not exceed, our requirements are to meet, if not exceed, all of the comparable emission targets that have been forwarded by the EPA and the European Union. Our testing thus far has shown that we are meeting or exceeding even the standards that are set for this facility. So we're very proud of the construction of this facility and the technology that's in use here. So an emission study by the US EPA looked to compare whether it was better to burn or bury waste when considering greenhouse gas emissions. And if you look where the arrow is pointing, you'll be able to see that EFW facilities, generally speaking, have the lowest emissions when you're comparing them to landfill of the same amount of waste. So it is a much better method of managing our waste, certainly locally, instead of transporting the waste. In terms of cap and trade, this is a discussion that's underway right now in Ontario. Ideally, cap and trade, we would look to offset carbon credits under the Kyoto Protocol Clean Development Mechanism, where 40 other EFW projects are included thus far, as well as the Verified Carbon Standards program. So far, we have 3 Covanta facilities in the U.S. approved under this scheme. Currently, right now, EFW is excluded from the European Union Emissions Trading Scheme. It's also excluded from the Regional Greenhouse Gas Initiative, nor is EFW included under the Quebec Cap and Trade Program under their Appendix A for that program. Originally, EFW was included under the California Cap and Trade Program, but once lawmakers there realized that it wasn't an effective way of including EFW under cap and trade, it's been exempted because of the consistent showing of GHG reduction. So putting it under the cap and trade program just wasn't applicable, and they started realizing that. So ideally, as Ontario moves through its cap and trade policy and sets that up, the same realizations will be met that energy from waste should be seen as a carbon offset rather than a carbon generator. That brings to a close our presentation. I didn't know if we wanted to do questions now after this presentation or together as a group at the end.
Well, we can take questions now if there are any from the group. I haven't seen any come up in the chat yet, but I have a question. And Joseph, you might be the one to answer this one. I'm not sure. So you mentioned that the facility will eventually generate enough energy to power 10,000 homes. Are there any plans to kind of expand the capacity to create energy?
The facility was built and the property was purchased to go up to 400,000 tons a year. The facility itself that exists has expandability to take us up to 250,000 tons a year, which then would take us to about 50 megawatts of power. If we go to the 400,000 tons a year, then we would have to build an adjacent building to the existing. So we have incorporated expandability into our plan and into the design.
Great. I just see a question pop up here. Okay, so this question is, with regard to the acreage / megawatt produced, was there significant NIMBYism for having any local facility footprint within the region?
Joseph, do you want to address the stakeholder consultation?
I'm sorry, I missed the question.
So the question is, was there any significant NIMBYism for having any local facility footprint within the region?
No. And it continues. Basically, it's been most of the population, we did do a survey, are in favor of this, but it appears that, as in most projects, there is a very vocal, very active opposition. And we answer the questions. As you can see, we went out of our way. We did quite a bit of public consultation. The ministry acknowledged that. We have a website that has all our documentation on it. We're very transparent. And once the facility does reach commercial operations, all our emissions will be posted on the website. So we are transparent. Will we in any way sway some of these people? We hope, but probably not. So there is NIMBYism ongoing here.
Right. Okay, we have another question here. How do you calculate carbon offsets from an energy from waste facility?
Jennifer, we did that study. I don't know if you want me to start and then you can chime in.
Yeah. Would you mind?
Basically looked at, I'm sorry?
Yes, please.
So we initially did a study whereby we looked at the energy from waste versus the long haul disposal in landfill and what the difference was there. We also have the offsets for the electricity generation that we put in place, and then there is the offsets for the metals that are collected at the end of the process. Those were the three mechanisms for greenhouse gas offsets. Jennifer?
Mm-hmm. Similarly, at Covanta's other facilities, they've done more of a holistic investigation into the carbon offset, and the general number that is used by the US EPA is that turning waste into energy, one is the equivalent of 1 ton of CO2 equivalent for each ton of MSW that is combusted. So that's the general number that the US EPA has put forward after extensive study, and that's the number that's put forward as we look at the carbon offset and point source comparison for these kinds of facilities.
Perfect. A couple more questions here. One question is, can Covanta speak in more detail to its presence with regards to carbon credit markets and how their business model may change as a result?
That's a really complicated question, and I think requires a bit of a lengthier discussion than what we have ability to talk to during this webinar. But
right.
Generally speaking, we do have a very active government relations sector within Covanta. We have a group of people who that's their full job is to liaise with various governments to continue to push energy from waste as a carbon offset technology. Certainly business models change continuously. We're seeing it with the metals market and the drop of metals prices right now. It's affecting our business forecasting. But as with anything, all we can do is continuously educate lawmakers and educate the public in regards to the technology and the benefits of the technology, and then work with governments as they develop their policies to make sure that our business model is an effective one.
Great, and we're going to do one more question, and then we'll move on to the next presenters. And I apologize for not being able to get to all of them, but again, we can follow up with our speakers at a later date. So the question is, does any of Covanta's plants utilize the waste heat?
Yes, absolutely. We have a prime example of that would be our Covent Niagara facility in Niagara, New York. They produce both steam and energy. They have 9 industrial facilities in their industrial park that they feed steam to, and those facilities use the steam generated to power their facilities. In total, there are 800 employees in other facilities that benefit from the steam power that Covent and Niagara generate. In addition to the steam power that they generate, they also generate power for the grid in the same way that our facility will generate power. And if one of the boilers at that facility have to go down for maintenance, they actually have 2 separate, smaller natural gas operated boilers that they can operate to ensure that they have the steam that is required for their industrial facilities in the industrial park. So that's something that, that Covent and Niagara does quite effectively. The Durham York Energy Center does have that capability once this, business area is developed further. We do have that capability.
Great. Okay, well well thank you, Jennifer and Joseph, for your presentations. We'll keep you on the line, and we'll pass the presenter controls over now to Stephanie Thorson with the Biogas Association. So Stephanie, just give me a second to pass you the controls. And I will unmute you.
Great, thanks very much, Jennifer. I hope everybody can hear me now. My name is Stephanie Thorson. I'm with the Canadian Biogas Association, and I'm speaking to you today about our Closing the Loop initiative, which involves generating energy from organic waste. We have recently published this Closing the Loop primer, which is on our website at www.biogasassociation.ca. It's available free for download, primarily for municipalities, but some food processors may also be interested in the publication because they generate organic waste that can then be converted to biogas and upgraded to renewable natural gas. So on the municipal side, just to back up, the primer deals with a number of issues that will help build the demand and supply for renewable natural gas, which is derived from biogas. And the funders for this primer are Growing Forward 2, which is a federal, provincial, territorial initiative, Bullfrog Power, Union Gas, and BioN Power. So we thank them for their support. So renewable natural gas is actually totally interchangeable with conventional natural gas when it's injected into the pipeline. It's just methane, CH4. And we're promoting it as the next renewable fuel because of both economic and environmental reasons. So the economics I'll get to in a moment. From the environmental perspective, transportation is the largest contributor of greenhouse gas emissions in Ontario at 34%. And it's very difficult, as any fleet manager will tell you, to reduce GHG emissions from transportation. Switching to conventional natural gas is a very effective way of reducing GHG emissions. And then switching again to renewable natural gas or blending in renewable natural gas into a CNG vehicle engine further contributes GHG emissions, and I'll get to the exact numbers in a moment. So renewable natural gas comes from 3 municipal sources in particular. Organic waste or green bin waste is the process that's really illustrated through the waste collection vehicles here. Frank will be speaking in a moment about RNG production from wastewater treatment. And lastly, landfill gas is a major source of RNG production particularly in other jurisdictions, but in Ontario we have some examples where it's converted to electricity. Again, here we're talking about converting it to renewable natural gas. So in this case, the closing the loop really refers to collecting organic waste and then using that very same organic waste to fuel the vehicles that go around and collect it, which closes the loop and has really made a lot of sense to some of the municipal waste collection operators. They really see the beauty of using the waste to fuel the trucks. So these trucks would need to be compressed natural gas fueled. They would bring the green bin waste to an anaerobic digester, which then upgrades, which then treats the organic material collected. And you get a couple of different byproducts. You get a liquid discharge that goes to either the sewer or another water source. There is also a digestate, which is the organic material, which is then recycled essentially back to the land. It's applied back to the land. And then the energy is produced, which can be purified, compressed, and injected either into the natural gas pipeline and then piped to vehicle fueling stations anywhere on the natural gas pipeline or on site. So here you have a waste collection fleets are increasingly moving over to CNG as the fuel. And here you have just an illustration there of how the fueling station can be either located at the anaerobic digester or again anywhere on the natural gas pipeline. So that is our illustration of the closing the loop concept. So this is the important part when you're trying to sell this concept to your colleagues or your political masters that have to balance budgets. The economic argument for RNG as a vehicle fuel is quite strong in that, well, first of all, this fuel is really suited to return to base fleets that are converting to natural gas anyway. So you've got your waste trucks. Transit vehicles are another large trend, and again, Frank will touch on that. Any fleet that comes back to a base that can be refueled, because we don't have a vast CNG refueling infrastructure in Ontario at this time. So you can supplement conventional natural gas with RNG to reduce the greenhouse gas emissions. And you'll see on this chart here, gasoline and diesel prices running around $1.15 per liter. Compressed natural gas is actually about half that price. When you blend in compressed RNG, which incidentally is about the same price as gasoline and diesel, you see that the blending at a 90%, 10% ratio only increases the price by about 5 cents a liter. And the economic case is very strong still against gasoline and diesel-powered vehicles. When you look at the GHG impact, however, the base case being gasoline or diesel, you get a 25% reduction on conventional natural gas. Compressed RNG is about 90% GHG reduction. That is the sort of industry-accepted standard used, particularly in the United States, where it's more broadly used. And in a CNG RNG blend, using these numbers, you get a 30% lower in base case with that blend. This data is from the California Air Resources Board from 2012 numbers, and it again compares the fossil fuels that are pictured in blue with renewable alternatives that are pictured there in green. So you see those three bottom sources indicate the GHG comparison compared to gasoline and diesel. RNG from a landfill, which is quite widely used in the U.S., has a significant GHG reduction. When you factor in RNG from green bin or source separated organics, the SSO RNG figure there, it's actually a carbon negative fuel. In the case of wastewater treatment plants, it's really carbon negative. So overall, the average is taken to be about a 90% reduction. The $4 to $15 per GJ is the cost to produce the fuel on average using the California data. So any municipality that does go down that road of looking at RNG as a vehicle fuel, you won't be first. We've got Nanaimo, BC, which currently generates electricity from their landfill gas, but they are in the process of constructing a RNG upgrading facilities, and they'll be fueling the garbage trucks that are used in Nanaimo with their landfill gas. That project was funded from a number of sources, including the Federation of Canadian Municipalities. Surrey, BC is building a SSO treatment facility that will fuel the waste trucks as well, and that was under a P3 business case. They built the business case based on comparing gasoline and diesel prices, and were able to make the case to convert their waste trucks to CNG and RNG. Hamilton's wastewater treatment facility is complete, and Frank will discuss that. Niagara is looking at converting its wastewater treatment facility to produce RNG as a vehicle fuel now. They had an RFP that has been awarded. London is studying the opportunity to collect SSO and convert it to RNG as a vehicle fuel. St. Hyacinthe and Rivière du Loup in Quebec are also under construction. There are some impressive municipal incentives in Quebec that help the business case, and we can expect to see more development in the months and years to come in Quebec. In Ontario, I've mentioned some of these. The picture on the left is a facility in Elmira, Ontario by BioEmpower that takes commercial waste predominantly and produces about 2.5 megawatts of power. However, they are able to accept municipal SSO, and they're looking to develop that market. They're also talking to a number of municipalities about treating their waste and the economics of using RNG as a vehicle fuel. And we're getting a very positive reaction to that. So we're optimistic that this will increasingly be the case. In the United States, Clean Energy Fuels has a branded RNG product called Redeem. I encourage you to watch the 2-minute video. It gives you a good background on how this all works in the United States. The Renewable Fuels Standard policy in the U.S. encourages the development of RNG as a renewable fuel. In addition, California has a low carbon fuel requirement that means that a 10% reduction in the intensity of the fuels has to be achieved by 2020. And in the United States, fuels have a renewable identification number, or a RIN, which is a system of tracking the batches of fuel that are produced and distributed across the United States. We do not have such a system in Canada, but if we did follow in the footsteps of the EPA in the US or California, it would make for a better, we'd have more production, and we'd be able to have more of an international market in RNG and be able to reduce GHG emissions. It was very encouraging recently to sit around the table with some GTA municipalities to discuss the opportunity to create RNG and use it as a vehicle fuel. So Enbridge Gas hosted a meeting with the Canadian Biogas Association, and City of Toronto already digests its green bin waste, has been looking at RNG for a number of years, has been studying it, and identified some of the barriers and opportunities and are looking to partner with Enbridge on a pilot project in the coming years. The several other municipalities that are and regions that are studying anaerobic digestion and planning to implement it as a predominantly as a source separated organics treatment facility opportunity are watching this with interest, and I think we'll study the successes and experiences in that pilot and consider going down the same road in the coming years. As you're familiar, these things take time, and so we're looking at a longer-term investment in the development of some of these facilities as, for example, composting contracts expire, and if some municipalities wish to divert more material such as diapers or pet waste, or if they have a need to treat the material within their borders, anaerobic digestion is the path that they seem to be taking. Similarly, Simcoe County is looking to investigate alternatives for the future too. So we're really seeing some exciting momentum, and if anybody has any questions about how this all works, certainly happy to answer your questions. Can take some after Frank completes his presentation as well. Thank you.
Thanks, Stephanie. So yes, we'll pass it over to Frank now. So Frank, let me just pass the controllers over to you. And okay, we should be ready to go.
We are good to go. Well, good morning, everyone, and thank you all. Thank you, Quest, for this opportunity to share with you a little bit of the Hamilton experience and hopefully provide some insight to you folks listening to this. Maybe give you just a little bit more encouragement to go ahead with the next opportunity. So with regards to the city of Hamilton, hopefully you all know where we are. Yeah, located right in the heart of the province, as we believe so, and that's key. Just from this perspective here about the city of Hamilton, like Durham Region, we see it's a growth situation. And looking at these statistics, it sets up the concept that we have to plan for the future, plan for what's coming ahead. And considering what we've done in our energy program, these considerations, these elements here were always in the background, seeing that we have a population that's expected to grow by 2031. And the area that the services, it's a large area, and again, growing in terms of industry and the transition in the city of Hamilton from the steel city to a more Hamilton Health Sciences and Educational Center. It's an encouraging time to be in the city of Hamilton. Directly dealing with the Office of Energy Initiatives, this was something that the City Council mandated back in 2005. It's created the Office of Energy Initiatives. And we're successful in dealing with the programs through what we have is the corporate energy policy. So it's a policy that steers us, gives us direction for energy projects, energy policy, managing with commodities. And as you can see there, the other key to it is we've established targets. So we have committed to reducing our energy intensity, and we've committed to reducing our emissions. We've had some good success. The initial 2020 target, we've already achieved that 20% reduction. And so we're looking for more ways to, again, reduce and to conserve. And again, the emission side of things goes hand in hand. There's a strong commitment to reach that 20% target, which we're very close to already. But we're thinking that we can do more, and some of the activities that we have that we're going to talk about are going to help us get there. So having policy from a municipal perspective was a key to success. Some of the typical things that we look at in that energy efficiency project. Let's see, Hamilton has been very active with district energy with the heating and cooling loop. promoting energy efficient lighting and controls. The ice arena refrigeration activity, we've focused a lot of attention on that. Like, most communities, we have like 18 or 19 community arenas throughout the city, so they represent a fairly significant energy consumer. Our Hamilton water operations, which singularly represents about half of the total energy used by the city corporation of the city of Hamilton. And we'll talk a little bit more about what's going on in their world. And water efficiency activities as well. We do have a tendency to focus on electricity and natural gas, but there's still good business cases for water efficiency activities. And as technologies has advanced, particularly in solar voltaic PV, we are active in that to a small degree, but with some of the changes that the IESO and their programs are proposing in the FIT and microfit and LRP, large renewable projects, I think we're going to increase our footprint in that area as well. The benefit to all that activity financially to the city has been through incentives. No question that they do assist us in making some of those decisions, but it does come down to a good solid business case. And the assistance from the IESO and programs, no question that that's been a big part of it. The exciting thing, and Stephanie touched on this, CNG for transit. We're just in the process now of completing the reconstruction and upgrade of our compressor stations for our transit facility. We currently are committed to 35 to 42 CNG buses for this year and the first quarter of next year, but that's going to grow to about 126 over the next 3 to 5 years. So the city has made a commitment to CNG, one for the business case that it presents, again, Stephanie had mentioned earlier on, and again, a commitment to GHG and emissions improvements. So that's how this ties together with today's topic to a certain degree. I will get back to that. The other element that the city of Hamilton has that ties in with taking advantage of opportunities from waste is the energy commodity procurement. Managing those sources of energy gives us some flexibility as to how we go about dealing with the likes of union gas, with the likes of suppliers. So from a business case, we can manage those costs, and it also allows us, when the time comes, to participate in that cap and trade program. So these are just some of the other activities that the Office of Energy Initiatives pursues to help manage costs. And at the way we present it, when council sees ask the question, what have you guys done for us lately? This is what we like to illustrate to them. Since the program's inception back in 2005 and up to just end of last year, 2014, cumulatively in about a $38.7 million cost savings or avoided cost. So it's a good news story and allows us from the Office of Energy Initiatives, working with our public works people, to go to the next step, to take on the next program. And so we have that confidence to take on some of the more challenging projects. Throughout that process, as the energy program evolved, relatively early on in the process, when the rules were unclear as to how to participate in the Ontario electricity market, the City of Hamilton created what is known as Hamilton Renewable Power. And it's essentially a sister company to the city that operates our landfill gas operation and our Woodward wastewater treatment cogeneration plant. So it just sets that up so that we have a different business entity, so it allows us to procure through a different process, and just gives us a little bit more flexibility and adaptability. The key to it is the last bullet point there, the annual revenue of about $2 million paid to shareholder of the city, and that's what really gets people excited. So to start with, a conventional Glenbrook landfill site started operations in A1, currently consists of about 104 acres and has an approved footprint of 156 acres. So this property handles all the municipal waste that comes from the six regions the six municipal towns that make up the city of Hamilton, Dundas, Ancaster, Flamborough, Hamilton itself, and Stony Creek. So it's one central location for all the landfill. Located at that particular site, we have two methane gas fuel generators that are rated at 1,600 kilowatts each. The project itself had that payback of about 4 to 5 years with a 21% internal rate of return. The other benefit to it was that it became an effective means for odor control. Now it is a fairly remote location, so there's not a very densely populated area, but we did get complaints, and we've reduced those to about 1 or 2 a year now. So that's a benefit as well. And it's generating about 18 million kilowatt hours per year. And we do that through a power purchase agreement with the IESO. The other opportunity, other source for our waste, energy from waste, is our Woodward wastewater treatment plant. That's just a little area view of it. But what's unique about this is for the city of Hamilton, excuse me, this system processes virtually all of the wastewater that the city of Hamilton generates. So it's all centrally located, and that allows for some engineering, ease of engineering when it comes to siting energy systems. At that location, we have as I mentioned earlier, the 1.6 megawatt cogen unit, pictured there on the left-hand side. And yeah, that is the world-famous globe. So that's our methane storage tank. That's really visible from the island. And adjacent to that is the biogas purification unit. And this is the system, the most recent addition to our fleet in terms of renewable energy. And we're taking methane from the anaerobic digestion process, purifying it, scrubbing it, purifying it, and injecting that back into the union gas grid. So we are a gas producer. So that cogen plant, 1.6 megawatt, at a cost of $4.4 million in 2005, I believe. Sorry, 2004. Has the ability to offset, capacity at 15,300 cubic meters a day. So it consumes a fair bit of methane that was normally flared or released through the digestive process. So now we're benefiting both in the energy recovery there and, of course, in the control of GHGs. So that's been a very successful, operates at a very high reliability, and the waste heat is also utilized in process for the digesters. Fairly recently, about 3 years ago now, there was an upgrade and enhancement to digester systems at the Glenbrook plant, and one element to that was incorporated was the biogas purification unit. As the project was in the engineering stages, one thing that had to be considered is what type of volumes that we would anticipate. You recall one of the earlier slides mentioned how we see population growing in years ahead. So the consulting group that we had at the time provided us with this information to give us an idea as to what kinds of volumes we anticipate when that growth happens. And that was key because as we went about making the selection for the equipment, it's important that you size the system up appropriately so that it can operate in this particular sweet spot. So as a result of that process, that design and consultation, we looked at 5 different purification processes, and so the water scrubbing technology that we have today was selected. And the system, size-wise, has the ability to process up to 10,000 cubic meters per day, for up to 1,200 homes. And as I said, we do inject gas into the Union Gas distribution grid. Gas quality is rigorously monitored at the unit itself by both the City of Hamilton and by Union Gas. And a fair bit of engineering went into the gas metering station. It's both pushing and pulling, if you will, as far as natural gas is concerned, so that we can be fairly accurate with the volumes and measurements of gas going in and out. So during the construction stage of it, there were some challenges. There was a fairly tight location and timing. So you can see the unit is fairly condensed into virtually a shipping container. And there you can see the scrubbing towers that are pointed up towards the sky. And everything is self-contained in that unit. The cooler condensers are up on the top of the green camera, and within the unit itself are the compressors and water compressors, and control systems are all within that box there. To make that happen, there is, of course, some administrative parts to it. As I said, we're producing gas, renewable gas, that system there. And so there is a contractual commitment there. We have to advise Union Gas as to the volumes that we produce on a daily basis, and we have certain tolerances that we have to deliver. So their forecasts for their requirements are, they're aware of those, and they can manage their system as well. Over time, we've learned the hard way as to the kinds of volumes that we need to forecast and what conditions set up for maximum gas production. So our operators at the wastewater treatment plant have become very adept to managing the treatment process so that we can increase the yield for methane, which allows us to produce more gas. And just how much gas, and this is the renewable natural gas component. So this is just the output from the biogas, and this is what we experienced in 2014. Now the gas itself is not directly coupled to a dispensing unit to fuel any of our particular vehicles. It does get injected into the Union Gas overall, so molecules are in the Union Gas system. But because we are measuring it very accurately, we know exactly the volumes of renewable natural gas that we are producing, and so we can track that in that fashion. So you can get a sense of the type of volume that the system produces, and then to equate that to give it some monetary value. What we're using here is $1 per GJ at the Dawn settle price. So Dawn is a Union Gas transfer point for gas within the province of Ontario, and the monthly prices were posted there. And until we get to a point in the Ontario market where we have a legitimate commercial price for renewable natural gas, this is how we're evaluating performance of the biogas unit. So all in all, for a system that on its own was roughly about a $2 million investment, and you can see the return there of about $116,000. So somewhat lengthy, simple payback, but again, based on just current market prices for conventional natural gas, we would expect that to be even a better return if the renewable natural gas market does become sophisticated and legitimate. But it's also adding to our commitment for greenhouse gas emission reduction. So all in all, the City of Hamilton experience, if you will, to tie all these things together to leverage the expertise of our people in Hamilton Water, our people in the Energy Office, we leverage the results of that. I mentioned the $32 million that's cost avoidance and energy savings. armed with an appropriate energy policy that gives us guidance and direction as to how to go forward with our goals and targets. All in all, it's completely the loop where the city of Hamilton, city stakeholders, and Union Gas and Hamilton Water are all benefiting from all these activities. So that is essentially what I'd like to present to you folks today. And together with Stephanie, if you have any questions, do our best.
Thanks so much, Frank. That was great. We are getting close to the end of the webinar, so what I'm going to do is hold off on questions for now, and I'm going to pass it to Kieran. If there are any questions for Frank and Stephanie, please feel free to type them in the chat box, and we'll see if we can get to them at the end of the webinar, and if not, then I'd be happy to kind of filter any questions towards Frank and Stephanie. So I'm going to say thanks for now, and Kieran, I'm going to pass the controls over to you in just a second.
I just get confirmation that you guys can hear me, or someone can hear me?
Yes, we can hear you. Perfect.
Okay, fantastic. Okay, just waiting to see that the screen loads. Yeah, sorry, apologies. I'm having to speak through my phone. So, anyways, my name's Kieran O'Connell. I'm the senior engineer with the Neighborhood Energy Utility here in Vancouver, and I want to talk to you about two things: our utility, the Southeast Falls Creek Neighborhood Energy Utility, and here we go. Sorry, and the low carbon district energy strategy that we have created as a result of our success with this utility. So, first, Southeast Falls Creek. What is it? It's a large neighborhood in central Vancouver, which has a long history of industrial use for the last 120 years. So it's an 80-acre brownfield site. There is the city plans are to install about 6 million square feet of development, which will house about 16,000 new residents by 2020. And the city of Vancouver really wanted to make Southeast Falls Creek a sort of landmark sustainable community in Vancouver, and that involved initiatives around in a whole host of areas, but the one I'm going to focus on, of course, is the energy strategy, which of course the two parts is sort of the supply side and the demand side. So energy efficient buildings, and we made the decision to install a low carbon district energy to supply all the heat and hot water to the neighborhood. So this is Southeast Falls Creek for you, anybody who's been to Vancouver. So you can see substantial neighborhood, centrally located, close to downtown. Sorry, moving back here. That picture was taken, looks like about 2000.
Kieran, we seem to have lost your audio there.
2008.
Oh, there we go.
You can see all the cranes under construction. Tabs are the grid energy plant, and then we have, yeah. Sorry, Stephanie, or
we can hear you now. We can hear you.
the city of Vancouver. In the province of British Columbia, all utilities are, in terms of their rates and their economics, are regulated by the BC Utilities Commission, with the exception of utilities which are owned and operated by 100% by a government body. So in this case, we're regulated by our city council rather than the Utilities Commission. The operations are managed by the City of Vancouver Engineering Department. But the utility, the way it works is basically it's all the capital costs associated with building the utility and the operating costs to run the utility are recovered through the rates that we charge to customers. So it's not like it sits as part of the tax roll with the rest of the city. Okay, so this graphic basically in a simplified manner explains how the utility works. So I'll walk through this graphic. On the left is a typical building in the neighborhood, and on the right is the Falls Creek Energy Center where we produce hot water for the neighborhood. So starting with the energy center, sewage comes into the plant through a typical gravity sewage system. We have a sewage pumping station in the facility, just like any other pump station in the city. The difference here is that we take a bunch of the sewage aside, we send it through basically a large heat pump, so a vapor compression cycle heat pump, pulls heat out of the sewage, puts it into the hot water system, and we pump that hot water out to the neighborhood through a buried hot water system, just like any other sort of typical hot water community heating system. Inside each building there's an energy transfer station. That energy transfer station pushes that heat into the building systems, and as I said, we typically provide both heat for all the space heating and ventilation make-up air and for the domestic hot water in the building. And then it's a two-pipe system, so the cooler water comes back to the plant where it picks up more heat. So that's a really simplified explanation. So the Falls Creek Energy Center, that's a picture of it on the right, is the central component of the system. As I said, we recover heat from sewage. That provides about 70% of the heat to the system. The remaining 30%, we use natural gas boilers, which we use basically to supplement the heat that the low carbon technology can provide. So it's a peaking and backup service. It supplies heat on the coldest days when the sewage heat recovery system can't produce enough energy, and it supplies a backup role in case the heat pump goes down for maintenance or failure or something like that. It's a picture of our distribution piping system in the early days. And then inside each building, as I said, we have an energy transfer station. So this is a graphic and a picture just to give an idea of what it looks like. And current status of the utilities that we're basically hitting all our performance targets, which are our targets are to get 70% of the heat from sewage and reduce greenhouse gases from a business as usual case by about 56%. And last year we were at 68% of our energy from sewage, and 55, which led to a greenhouse gas reduction of about 55%. And we have economic targets, of course, to keep the utility competitive with business as usual, and that is the case if you compare it to any other low carbon energy source. The rates are the same or less. And of course we grow every year. We add new buildings, connect new buildings to within the neighborhood to supply heat and hot water to those buildings. So just a summary of the benefits. All the energy is locally sourced from the neighborhood. It's renewable, low carbon. The system, of course, is adaptable. It's a low temperature hot water system, so any other waste heat source in the neighborhood would be connectable to the system, and that's really what we've achieved, is building infrastructure which can accept energy from a wide variety of sources. It's cost effective in terms of supplying low carbon energy to those buildings, and it provides competitive rates while supplying a return on investment to the city. So I'm just going to switch track a little bit and talk about where we're headed from here. So with the success of this utility in Southeast Falls Creek, the city's establishing and implementing a district energy strategy across the city. This is sort of a classic graphic from a Swedish example of district energy, where they began. I won't walk through every single color in the graph, but think of the stuff on the bottom, the purple, and as being fossil fuels, and the other colors towards the top as being renewable sources. And you can see how over time, I mean, this is over a time span of this is from 1970 until 2004, just how the diversity of supply and building a platform which can accept a variety of waste sources has led to, you know, a dramatic reduction in the amount of fossil fuels that they need, and create a real high level of not only use of renewable fuel, but a diversity of supply. Yeah, it's just a graphic which sort of highlights the number of and variety of energy sources that are connectable with a system like this. So, I mean, electricity is often used, oil, biomass, natural gas, coal. You know, we have solar thermal systems, we use sewage heat recovery, and of course waste heat from industry, and the energy supply is useful by commercial, industrial, and residential customers. So from this, as I said, we've began work on and have made quite a bit of progress on what we call the neighborhood energy strategy. So we implemented a strategy and laid out a strategy in 2012, and this graphic shows some of the targets that we need to hit, and how this is an important piece of the city's strategy to reach these targets. So in 2010, we had a target of reducing our municipal operations by 20%. We achieved that target. 2012, to reduce community emissions by 6%. Our real targets begin in 2020, where we need to, through the Greenest City Action Plan, to reduce community emissions by 33% below 2007 levels. 2030, we have to have all new buildings carbon neutral. In 2050, we need to reduce community emissions by 80%. So Vancouver's emissions profile in 2008, the big slice here, and the one that we're addressing, of course, is the buildings on the right, where it was 55% of our greenhouse gas emissions. Almost entirely, the rest of the graph is transportation, with solid waste being a small portion as well. Okay, so the strategy for district energy, we pieced it together out over the next 3 slides. We needed to look at first, where are the existing district energy systems. So there's 3 large steam networks in Vancouver. We have a central heat, which is a large downtown centralized steam system. We have the Southeast Falls Creek Neighborhood Energy Utility, and then we have 2 hospitals along Cambie Street, which are VGH and Women and Children's Hospitals, and they're interconnected by a steam line. And the black lines, of course, are the major transportation corridors, the Broadway corridor and the Cambie corridor. Overlaying on top of that is major areas of redevelopment in the next 20 years in Vancouver in green, and you can see from the last slide there's a little bit of overlap. This is a map essentially of all the existing hot water boilers in Vancouver. You can see the density of these existing boilers aligns to a certain degree with the prior two slides. And then this slide really combines all three of those elements, which is the existing steam networks, the planned redevelopment sites, and the areas where there's a large density of district energy compatible buildings, and how, with looking at these areas where these overlap, there are areas where the city sees a lot of potential for district energy, and those are basically downtown and the Cambie corridor and the Broadway corridor. So the city's strategy is to, through rezoning and other municipal tools, develop new neighborhood energy systems downtown and along the Cambie corridor and along the Broadway corridor, using whatever technology is appropriate. So that in the case of downtown will be using the existing steam system, and in other parts of the city, particularly farther down Cambie and along Broadway, would be new hot water systems. So sorry for the rushed presentation. This is my last slide. This is just a forecast of the greenhouse gas reductions that we hope to achieve in the coming, between now and 2025 through district energy, and this is a mixture of the existing systems where we have the Southeast Fall Street neighborhood energy on the bottom, and a number of other new planned systems, and then the conversion of the two large existing steam networks to low carbon sources. So again, apologies for the rush, but I guess from now I will turn it back to questions.
Yeah, thanks, Karen. We're getting to the end of our time here. If there are any questions, I'll encourage you to type them in the chat box. So I'll give you about 30 seconds to type something in there. If not, then if any questions come up after we've ended this webinar and you'd like to get in touch with our speakers, please go through me and I will make the connection and facilitate that. So at this point, I will thank our speakers for joining us. Thank you, Karen, for getting up bright and early in Vancouver today and joining us for this morning webinar. Thanks, Jennifer, Joseph, Stephanie, and Frank as well. So as I mentioned, this is the third of a 5-part summer webinar series, and you can find out more about the rest of the webinars at questcanada.org/Ontario. The next webinar is going to be August 18th, and we're going to be looking at the marketability of home efficiency. And the final webinar will be August 26th, and we're going to be looking at how to develop a successful municipal energy plan application. So thanks again, everyone.